In this video, we're going to talk about how ionic bonds form. And in general, ionic bonds are going to form when a metal reacts with a nonmetal. So here's my metal, here's my nonmetal. Nonmetals are mostly gases, so I have this cloud of gas here. When they come together and react with each other, we're going to have actually a really large release of energy, first of all. So we'll have this big kind of exothermic reaction, and exothermic means that energy is released or heat is released. So the exo means exiting the system here. That's going to happen, and we're going to end up with some kind of ionic compound. And most ionic compounds are going to form a crystal. There's many types of crystals, so like sodium chloride, also known as table salt, is going to form a crystal. Magnesium sulfate, which is also known as Epsom salt, will also form a crystal. And some even have really, really bright colors, even red and orange and blue. Now, ionic bonds are going to form when ions combine together. It's going to be a reaction with a cation and an anion. Now, metals form cations, and cations have a positive charge, and nonmetals form anions, which are going to have a negative charge. Now, these individual ions here have formed when an atom gains or loses electrons. And so when these two things get close to each other, we have our anion and our cation, they're going to be attracted to each other. It's the same kind of idea as a magnet picking up a piece of metal. So when you bring a magnet close to something like a paperclip here, it's going to attract that paperclip and they're going to stick together. That's the same kind of idea we have here with our anions. Now, when these ions stick together, there's a very strong bond that's formed. And this bond is the result of a force called the electrostatic force or electrostatic attraction. And this attraction of this force is so strong that it's going to cause ionic compounds to be solids at room temperatures. And they'll have very high melting and boiling points. Okay, so let's actually look at an example of an ionic compound so we can see how these ionic bonds form. So here's some table salt. If we can actually zoom in on a grain here of table salt, we would see what this stuff's made of. It's made of sodium and chlorine. And I've drawn the Lewis structures here for sodium and chlorine. So we can see that sodium has 1 valence electron and chlorine has 7 valence electrons. Now, atoms tend to want to follow the octet rule, which states that an atom desires to have 8 valence electrons in its valence shell. For metals, they're going to lose their valence electrons because underneath they actually have a shell with 8 electrons. And so metals will lose their electrons, whereas nonmetals, which chlorine's a nonmetal, will gain electrons to get 8. We can see that chlorine only needs 1 more electron, so if sodium gave its electron over here to chlorine, they would both be satisfied according to the octet rule. And so sodium is going to have a positive charge, and chlorine is going to have a negative charge. And so we're actually going to have this electrostatic attraction happening between these two charges. And so the way we can write this chemical formula is that we have NaCl. And since we're just putting one element of each, we don't need any numbers there to indicate that. We just assume there's one of each. All right, so that's one example of an ionic compound. Let's take